Divide and conquer is a pretty versatile algorithm design strategy that has applications in sorting algorithms like quicksort and merge sort, search algorithms like binary search, Fourier transforms like the fast Fourier transform algorithm, and quite a few more. But how exactly does it work? So we start with our original problem and break it down into smaller problems. So we're essentially dividing the original problem up. We then split those subproblems up again and again until we reach a stage where each subproblem is sufficiently small enough to solve. We usually use recursion for this, so we stop dividing when we reach the base case. At this point, we can solve and combine the subproblems to get larger subproblems, so we're essentially conquering all the problems. We can keep solving and combining until we have nothing left to combine, at which point we will have arrived at the solution to the original problem. We'll use the analogy of Lego to understand this a bit better. We'll start with this jumbled block of Lego bricks, and we want to recombine these bricks into this pattern. We'll use divide and conquer to do this. The first thing we'd want to do is divide this block in half. So these halves represent smaller subproblems. We would then want to divide these in half again, and again, and again, at which point we've just got individual blocks. This represents the base case because we can't feasibly break these blocks up any smaller. The original problem has been fully divided and now we can start conquering the subproblems. We'll start by solving and combining these two red bricks. We can keep solving and combining bricks until we reach a stage where we've got larger subproblems. We can then solve and combine these larger subproblems until we reach a stage where we have even larger subproblems, and we can combine these until there's nothing left to combine, at which point we reach the solution to the problem. In the realm of computer science, merge sort is a prime example of where we would use divide and conquer. I'm going to assume you know how merge sort works. We won't go into too much detail. This is more of a look at how it uses divide and conquer. So, if you want to see a more in-depth look at merge sort, let me know in the comments and I can make that for you. We start with an unsorted array, our original problem, and we break this down into smaller unsorted arrays, repeating this until we can't feasibly break down the arrays any smaller. Now that the unsorted array has been fully divided into subproblems, we can solve and combine those subproblems. At this stage, we can see that each subproblem has technically been solved, since an array of length 1 is already technically ordered. Then, we want to solve and combine the arrays. To do this, we can choose two subarrays, say the one containing the number 4 and the one containing the number 1, and then combine and solve these, which would look like creating a sorted array out of these two elements. We would do this for all the other subarrays until we only have one array left. This is the fully sorted array, and thus the solution to the original problem. So, to briefly summarise what we've learnt, divide and conquer is a versatile algorithm design strategy, which involves dividing the original problem up into subproblems, and then solving and combining those subproblems until there are no more subproblems left to combine, at which point you arrive at the solution to the original problem. If you have any questions, I do answer them all, so let me know in the comments and I'll get back to you as soon as possible. If you want to see more content similar to this, make sure you're subscribed so that you don't miss out. Enjoy the rest of your day and I'll see you in the next one.